Hello, beautiful people, and welcome. In today's video, we are going through your homework number 3 for Integrated Math 3. Just a reminder, that means your exam is on Friday and your homework is due on Thursday night. Please use this video as a tool to study and prepare for your examination and also for you to check your answers. Speaking of answers, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from my mistakes. I went ahead and I pre-highlighted some things for question number 1, which means that there are things that we are doing to our parent function f of x. Now, our function here is the absolute value of x minus 4, and we're going to stretch this function vertically by a factor of 2, and then we're going to bring up 5 units. So bring up that function 5 units. The way I would like to see this on a test is I'm going to ask you for a table. It helps me see your steps. It also helps me grade on partial credit. So you're going to start with your original. Then you're going to have your first change, which is vertical, and it's okay to abbreviate, stretch by 2. And then we have up by 5. Now, during class, I did ask you to write out your function notations first and then apply it to the given function. I don't have my graphic organizer with me, so I am going to write these out, but I'm not actually going to show you the graphic organizer. Oh, let's go ahead and write the original. Original, you have a choice to include that f of x section, or you can just write absolute value of x minus 4. Either is okay. Vertical stretch by 2. Vertical means outside. Since we are stretching, that means it's a multiplier. And since it's an outside change, we're going to be having an outside multiplier of 2. So our function notation is 2 times f of x. Since we have an outside change, we're going to take this f of x that we have here, and I'm going to replace the actual f of x by opening up parentheses. I'm going to bring in my f of x inside of the parentheses. So absolute value of x minus 4. Now, parentheses here are technically not needed because we already have absolute values, but I just want to make sure that you understand that you do this whether it is absolute value or not. So therefore, we do have an outside change. We cannot go inside of the absolute value. So our simplified version is 2 times the absolute value of x minus 4. Put this in a thinking bubble. This is your function after the first change has occurred. Moving on to the second one, up 5. Up, again, is an outside change. And we have outside 5, which means we're going to have function notation f of x plus 5. Again, since this is an outside change, we're going to open up for our function. Now, I'm not taking the original. I am moving on from step number or change number 1, and I'm going to bring my function here. 2, absolute value of x minus 4, absolute value. Now, this one does technically require parentheses because we no longer only have absolute value. We do have that 2 out in front. Next, since we have an outside change of plus 5, I'm going to take this plus 5 and I'm going to add it outside of the parentheses. Because we do have an absolute value function, we cannot go inside of the absolute value, so any changes that happen to the outside remain on the outside. So for our simplified version, we have 2 times the absolute value of x minus 4, close the absolute value, add the 5. Remember, I am asking you for an equation, and that equation is called g of x. Question number 2. Given the function g of x, write a function g of x. Well, that's a typo. So we can change this. We can either name this f of x or we can name this, switch these. Since this is already g of x, I'm going to call the changed one f of x. So this is definitely a typo. That's on me. Let's go ahead and see what they want us to do. We have a function that stretches. This should be g of x horizontally by a factor of 2. Okay. And then we have a translation down 2 units. Let's go ahead and create our table. Starting with our original. Our first change was we have a horizontal stretch by 2. Second change is we have down 2. Start out by writing your original function. I'm going to leave off g of x here. I don't want that to be confusing. Technically, that should have been an f of x. That's a typo. Horizontal, anytime you see the word horizontal, that is an inside change. So things immediately get weird when you see this word horizontal. Horizontal stretch, if you take a look at your graphic organizer, this is where we have a multiplier by a reciprocal. So that means inside of my function, let me change colors here. Inside of my function, I'm going to have a multiplier of not 2, but 1/2 times my x. Now, anytime you have an inside change, notice this is inside, you're going to be replacing original x. What that looks like is you're going to take your function. So our function here is the absolute value of 2. Let me change markers here in just a little bit. Notice how I opened up for my original x location. So here's my original x. Here's my original x. And I'm going to take my 1/2 x and put it inside of the original x spot. Now notice what I have. I do have absolute value here and here. So all of the changes that are happening on the inside. Since it is on the inside of the absolute value, we must simplify. I am writing a little bit on the larger side, so I'm not sure if I'm going to have space. Where can I find space? I'm going to have to squeeze it in. All right, so we got 2 times 1/2, which is just 1, so maybe I do have space. Absolute value of x minus 4, put that in the thinking bubble. That's our simplified version. Next, I have a down. Oh, I forgot my minus 4. Oopsies. Let me add that in there. Erase that. Oh, no, it's in there. It's in there. I thought I forgot my minus 4. It's there. Here's my minus 4. Here's my minus 4. It's there. All right. Down 2. This is an outside change, so be careful there. So we got f of x, and outside of f of x, we got a down 2. That's my function notation. So I'm going to take my function. I'm going to open up for f of x, have the minus 2 on the outside of my function. Now, what am I putting inside? Everything. I'm going to pick up this changed function, absolute value of x, minus 4. And now, since I am creating a change on the outside of my function, notice that I have a minus 4 also on the outside of the absolute value. So when you simplify, these two need to be combined. I can't go inside of my absolute value, but I can simplify with the outside of my absolute value. So for my actual function, I have absolute value of x. -2 and -2 is a -6. I'm going to call it f of x just to be different. Since originally we have g of x, I'm going to call this f of x. Or you can keep it as g of x to be the same. And then originally here, cross that out, make this into an f of x, because that was a typo. Okay, moving on. Next question, number 3. Given the function absolute value of x minus 4, write a function g of x that reflects f of x across the y-axis. So one change here. Reflects across the y-axis. Again, this table doesn't have to be that large. We only have one change on it. So we have our original, and we have a reflection across the y-axis. Again, you have a choice. You can write your f of x, or you can just write the absolute value of x minus 4. Again, function notation, y-axis is an inside change. So for function notation, we have a negative x on the inside. Anytime we have an inside change, you're going to replace x. What that looks like is I'm going to take my function. I'm going to open it up. Anywhere I see x, I'm going to open up for that x. Then I'm going to take my insides and I'm going to replace x with it. Go ahead and simplify. Well, it's inside. I can't really simplify anything. So we have absolute value of negative x minus 4. So this is something that you saw on homework number 2, where we can continue to simplify this. This is called factoring and a multiplicative property of absolute value, which means I can pull out, factor out, still on the inside, a negative 1 from x and 4. This makes x positive and this makes 4 positive. I want to be extra with my absolute value so you guys can see it. And then the multiplicative property of absolute value is I can go ahead and pull out that multiplier of negative 1 and have the x plus 4 in its own absolute value and negative 1 in its own absolute value. But what is the absolute value of negative 1? Well, that's just positive 1. And if I have a multiplier of positive 1 next to anything, it's just 1. So we're going to omit that and have just absolute value of x plus 4 equals g of x as our answer. Your answers must be simplified in order to get full credit. All right, let's go ahead and move on. I wanted to give you lots of examples of these. I am going to start moving a little bit quicker on these examples. Otherwise, we're going to have a 4-hour video, which I definitely don't want to do that. All right, given the function, let's go ahead and start. We want to write a function that shrinks horizontally by 1/6. Here's our original. And here's our horizontal shrink. You can also say compression by 1/6. Original, we have absolute value of x minus 2, close the absolute value, plus 5. This is a horizontal. Horizontal is always inside. We have a shrink or a compression, means multiplier. And since we have a inside change, that means we're going to have the reciprocal. For the reciprocal, we have our function notation as f of, take the 1/6, flip it. And now inside of our function, we're going to be replacing x with 6x. Let's go ahead and write this out. Take your original function, copy it down, open up for x. That is what we're going to be replacing. Bring in your 6x here. And then again, since you can simplify the insides if you can. Once the outsides, we can't bring it inside. But if it's inside, we can simplify. Here we can't actually, because we have 6x minus 2 that is unable to simplify. So we just write our absolute value, 6x minus 2, close the absolute value, plus 5. That is the only change that we have. Name it g of x. Given the function 3x minus 2, write a function that stretches vertically by a factor of 2 and reflects on the y-axis. So 2 changes here. Let's go ahead and make our table. We have 3x minus 2 as our original. We have a vertical stretch by 2 and a reflection on the y-axis. Writing out our function notation, vertical means outside. Stretch means multiplier. And again, since it's outside, we're going to have a multiplier of 2 times f of x. which means I am going to open up for my f of x, have my 2 here. F of x gets large parentheses, and I'm going to take my original function and I'm going to write it inside of the parentheses, 3x minus 2. This is a linear function. Be careful with linear functions. You must simplify, which means this is a distributive property. I'm going to bring my 2 inside. If you don't simplify, it would be marked incomplete and credit will be removed. So we have 6x minus 4. I'm going to put that in thinking bubble. That's our first change. Second change, we have a reflection on the y-axis. That is a inside change. So we have f of negative x, which means when I am writing out my function here, I'm going to open up for x, and I am going to be replacing with a negative x inside my parentheses. There we go. Again, simplify when you can. This is linear. We can simplify negative 6x minus 4. This is not an absolute value. We don't need to factor out a negative. And then again, we're going to call it g of x. Here we go. Question number 6. Given the function x squared, if g of x is equal to x minus 3, 2, describe, alert. We have now completely shifted on what they are asking us to do. Anytime you see the word describe, this is English. I am asking you to tell me in English what the transformations happened. Okay, so this I'm asking you to write math. This I'm asking you to write English. The way that I like to do it is always in the form of arrows. For me, that helps out the most because I can keep track of what the changes happened or didn't happen. So I'm going to take a look. Do I have anything here as an A value? Do I have any negatives? No. Do I have a B value? No B, no factoring. There's nothing to factor. I don't have a B value, which means that this value that I see here is my H. I see a negative 3. That means I have a positive 3. That means I go right 3. So that's my first change, my translation. Then I have an outside change of plus 5. And again, it's outside. Outside is your K value. K is for keep. So we're going to go up 5. And that's my second change. Now, if we take a look at question number 7, it is asking us to describe again. But look at the function that they are giving you. They are giving you a function with a b value. So g of x is equal to negative 2, open 4x minus 4, close it, square it, minus 5. This one does have a b value. And since it does have this b value, we're going to need to factor. To factor out that b value, I usually like to do this off to the side and then bring in my descriptors later. So I'm going to rewrite this. Let's write this a little bit better so you can see. 4x minus 4. We're going to divide by 4 by our b value. So if your b value is negative, divide by a negative. If your b value is negative a fraction, divide by a negative fraction. So whatever you have attached to your x, that's what you're going to be dividing by. But remember, this doesn't disappear. This gets brought out, and then you have your leftovers of 4 divided by 4 is just 1x. 4 divided by 4 negative is negative 1. This here is now what we have as separate. So I'm going to have large parentheses as separate insides. So we now have 2 double bubbles, double sets of parentheses here that I'm going to need to describe. Now, everything that doesn't match x squared needs a descriptor. Note that this negative out in front is completely different or not attached to this 2. which again, now we have this b value here that we need to describe. Now we have our true value. So this 4 here, I'm going to cross out. We don't have that 4. It doesn't exist. But what we do have is this 1 that we need to describe and a -5. Let's go ahead and write out our descriptors. Here on the outside with the negative, we have a reflection across the x-axis with a vertical stretch. Make sure to tell me by how much. By 2 with a horizontal. Remember, horizontal is a multiplier with a reciprocal. So that means I'm going to write here, I see a 4. That means I have a 1/4. So that means it's a horizontal compression by 1/4. Be careful on telling me a compression by 4. You can't compress something when you're making things larger. So this definitely you need to be aware. Next, we see a -1. That means we have, this is for the insides, a +1. That means I go to the right 1 and I shift down 5. Good. Let's move on. One more describing question. And again, keyword here is describe. Anything that tells you to describe, we do English. I am going to write this out one more time. G of x is equal to -1/4 open 2x minus 4 squared plus 5. Again, I did, when I copy this down, notice I do have a b value. That means I'm going to need to factor. To factor, I'm going to write this out. I have 2x minus 4, which means I'm going to be dividing by 2. That 2 does not disappear. It gets brought out. And we have our leftovers. 2 divided by 2 is 1x. -4 divided by 2 is a -2. So when I rewrite my function, I have -1/4, big open, 2, little open, x minus 2, close it, square it, plus 5. Let's see what we need to describe. I do see a negative out in front, which is not attached to this 1/4, which then we have a b value of 2, which then we have an h value here and a k value here. Let's describe. Out in front, we have a reflection across the x-axis. We have a vertical compression. You can say shrink as well, by 1/4, and a up 5. I skipped around here, be careful. I went all the way towards the end. Insides, be careful. I see a 2, that means I have a 1/2. That means I have a horizontal compression or shrink by 1/2. Here I see a -2. That means I have a +2. That means I go to the right by 2. Alrighty, I think that wraps up our transformations. I think we're moving on now to graphing. All the graphing that we're doing is from your Integrated Math 2 class. We're just reviewing quadratics. You need to know 3 different formats. The first format we see here is going to be your vertex form. We have f of x. You can also translate that as y, -1/4, open, 2x minus 4, close it, square it, plus 5. Anytime you see a b value, you need to factor that out. Just how we did in example 8 and example 7. So I have 2x minus 4. I'm going to divide by 2. Again, this 2 doesn't disappear. It's still there. 2, open, x minus 2. And I'm just now noticing that these two for 8 and 9, they are the same equation. So we have y equals -1/4, open 2, open x minus 2, close it, square it, plus 5. It's not asking us to describe, it is asking us to graph. Let's read. Use at least 5 points. It is bolded for a reason. On the graph, identify the vertex. That's another thing I'm looking for. And axis of symmetry. That's a third thing I'm looking for. Technically, 5 points, then vertex, then symmetry. What is domain and range of the function? So we're going to write that there. Make sure all points are clearly indicated on the graph. Please make sure that I'm able to read what you are graphing. If it is a guess that I have to do, I'm not going to be able to guess correctly. Let's go ahead and start with our vertex. For your vertex, remember, once you factor, you don't have this value. This 4 that I have in my H spot, it's not H. After you factor, then we're going to identify our vertex. And our vertex is opposite of what you see, H, K is for keep. But this is only after you have factored. So I have a +2, +5. Your axis of symmetry. This in your vertex or from your vertex form is x equals, and you're just going to bring down that x value of +2. When you're graphing, let's go ahead and immediately graph this. We're not done. We still need lots more points. When you're doing this, you're going to start with +2 here and then 5 here. So let's go ahead and create our point. This is our vertex. The axis of symmetry is going to go through that vertex. And now the axis of symmetry is going to be a dotted line. Please do not make this line solid. Dotted line indicates that we can't actually see it. So if I was to use a graphing tool like a graphing calculator or Desmos or any of those tools, we won't actually see this line, but it's there. Next, we're going to pick up a calculator and we're going to create a t-chart. For my t-chart, I'm going to start off with my vertex, which was +2 and 5. And I am going to go one direction. I'm not going to go 2 directions. I'm going to go one direction. And I'm actually going to use the original given function, not the factored, but the original. The reason we use the original is because of the extra parentheses that we've created. We don't want to have like triple, quadruple parentheses that can mess us up. So here's my original. This is very important. Anytime you see a fraction, make sure your fraction is in extra parentheses. I'm going to choose to go up. So I'm going to go 3, 4, 5, 6. This is where I ask you to give me pretty points. If your value ends up being a decimal, we cannot have decimal. Skip it and move on until you get something that you can graph via a whole number. Now, if all of them are icky, if all of them give you incorrect, not incorrect, but decimals, then pick the prettiest decimal, but we should get pretty numbers here. 2 times 3 minus 4, close it, square it, plus 5, and I get 4. Now, instead of retyping this every single time, I'm going to go up on the calculator. I'm going to go over, and this 3 that I inputted that right now is blinking, I'm going to just type in 4 and change it to 4. Enter. I get 1. Again, once again, 5, and I get -4. Once again, now how many points do we need? We need a total of 5. That doesn't mean 5 on the table. That means a total of 5, and I'll show you what I mean by that. No decimals, no fractions. That's great. So now we have our next point, 3 and 4. Now I'm going to reflect. So here's one jump, one jump. So right now I have a total of 3 points on my graph. So I'm going to plot 4, 1. Now I have 2 jumps, 2 jumps, and now I have a total of 5. Make sure as you're graphing that you give me smooth U. If it looks like a V, it is going to be marked wrong because that's a different pairing. We want quadratics, not absolute values. Smooth U. This is what 5 points look like with an axis of symmetry. I don't need you to write out what your points are, but I need to be able to read it clearly where your points are. I shouldn't be guessing what they are. Okay, domain and range. Domain, always, always, always the same for quadratics. It's from negative infinity to positive infinity. Remember, when you're writing this, you want your minimum value on the left and your maximum value on the right. Just like you would on a number line, smaller numbers go on the left, larger numbers go on the right. Now your range is dependent on your vertex. So you're going to take a look at your vertex, and we're specifically talking about y values. Here's your y value. Your vertex was 2, 5. So your x was 2, your y was 5. Do we have this vertex as a minimum value or a maximum value? Because we are going down, we have this as a max value. So your max is going to be your y value on the vertex, because our vertex is a maximum. That means that when we take a look at our arrows, we're going to be going down to negative infinity on both sides. So from negative infinity, open parentheses, to 5 bracket, because 5 is included. Let's move on. Question number 10. Staying with vertex form. Again, same steps. I am going to work a little bit faster here. Y equals negative 2, open 4, x minus 4, close it, square it, minus 5. I do see a b value, so I do need to factor that out. So that means I'm going to take my 4x minus 4, divide by 4. That means I pull out 4, it does not disappear. X minus 1 is what I have inside double parentheses. Y equals negative 2, open, 4, open, x minus 1, close it, make sure you have a squared, minus 5. That means I don't have this 4. This 4's gone. What I actually have for my vertex is my h comma k. Opposite what you see, so positive 1, negative 5, k is for keep, which means my axis of symmetry is this positive 1 for my axis of symmetry. We're going to open up a t-table. We're going to use the original equation, so negative 2, open 4 times x minus 4, close it, square it, minus 5. Start with your axis of symmetry, so positive 1, negative 5. Choose to go up or down. So I'm going to go up and say my inputs are going to be 2, 3, 4, 5. And is that enough? Maybe. We'll see. Picking up a calculator, I do not need parentheses around this negative 2. It's not a fraction. I'm going to type in 2 minus 4. Now the calculator will do order of operations here. If you would prefer, let me go ahead and delete this. If you'd prefer to put parentheses around here, that's fine. So if you do open 4, open 2, close it, minus 4, close it, square it, minus 5, that's also fine. And I get negative 37. All right. Let's see what 3 does, because I don't want to graph negative 37. So second, delete is not going to delete anything, but that's your insert button. So now I'm going to insert 3. You can see how it didn't change here, the 2. So if you do second delete and an insert, it's just going to input things, but it's not going to delete it. So I'm going to try 3. Oh boy. Yeah. I'm not graphing these. They're too small. But let's see. Maybe I did give you enough space. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. 20, 21, 22, 23. I did not give you enough space. That's okay. We can guesstimate of where they're at. And I'll show you how we can do this. You know what? I'm going to cheat. After all of my talks and lessons about no decimals, no fractions, what happens if we put in a 1/2? So Parentheses again would be needed because it is a fraction. So I would do -2, open, 4, open, 1, half, close it, -4, close it, square it, -5. Manageable. So here's an example of where a fraction, no decimals, decimals are not allowed, where a fraction is kind of needed in order to graph, and we want at least 5 points. So let's start with our vertex. Our vertex is at 1 and -5. Axis of symmetry is a dotted line. Please make sure you have it as a dotted line or dashed. Next, we have 2, and let's actually do that 1/2. So here's 1, here's a half. We go down to 13, 10, 11, 12, 13, negative. Reflect over here. So here's half a jump, half a jump. It's going to be here. And then we have 2 and -37. So here's 1, here's 2. -37 is going to be off the graph. So I'm just going to do it all the way off the graph. This is not drawn to scale. It should be lower. Reflect it over. I'd have 1 jump, 1 jump. So it's about here-ish. Be careful here. It's going to be very narrow, but you still cannot have it look like a V. It has to be a smooth U. My apologies for not giving you enough space. For domain, again, never changing for a quadratic. Your minimum is -infinity, and your maximum is positive infinity, open parentheses. Next, we're taking a look at whether we have a minimum or a maximum for a vertex. Our vertex was 1, -5, and this was a maximum here. We're taking a look for the range on our y values. Our maximum was -5, brackets. That means we're going all the way down to -infinity on the y values here. Open parentheses on infinities, close parentheses on your y values. Okay. Question number 11. Still on vertex 4. Now, if you notice here, I do not have an A value and I don't have a B value. Since I don't have a B value, I don't factor. That means this right here is my H, and I can immediately jump to vertex. Vertex is, again, opposite of what you see, so +3, +5. K is for keep. H is the only one we change, which means our axis of symmetry is x equals +3. Immediately going into the T-chart, starting with your vertex, I'm going to go 4, 5, 6. Is that going to be enough? Maybe. And I am asking you for at least 5 points. I am going to be writing out the original and putting my x values into the equation. Yes, parentheses like this are required because you are squaring it. So open 4 - 3, close it, square it, +5, I get 6. Go up, have your 4 blink, then change that 4 into a 5, I get 9. After the last example, these numbers are very pretty. And I get 14. All right, let's go in and start with our vertex. Our vertex is 3, 1, 2, 3, and 5. Axis of symmetry goes through the vertex. Please make sure it's a dotted or a dashed line. Cannot be solid. Next, we have our other points, which we have 4 and 6. Reflect over. So now I have 3 points. Next, I have 5 and 9. 2 jumps, 2 jumps, and now I have a total of 5 points. So I technically did not need my 6, 14 here. Smooth curve U. If it looks like a V, please erase it and make it look like a smooth U. If you've erased a couple times and you're like, I don't know if she's going to think that's a V, just write U-shaped. So that way I know that you know that it's not a V. Range and domain. Domain, x values does not change, -infinity to +infinity, open parentheses. We ask ourselves on the vertex, is this a minimum or a maximum? This one's actually a minimum. and our vertex was 3 comma positive 5, and we look at our y value for range. Since this is a minimum value, minimum goes on the left and maximum goes on the right. So our minimum y was 5, close it with a bracket, and since we're going up to a positive infinity, open parentheses. Alrighty, let's go ahead and move on. Next question we have is, this is actually something that I provided you a hint with. So here's our equation, and here's my hint. Let's go ahead and write this out. Negative x, open x plus 6, close it, equals g of x. Now, I did give you a hint that this is intercept form. Since this is intercept form, I am asking you as a part of a hint to write it in this format, which means I get negative. I'm going to open up my parentheses. I have x plus 6 here. You can put this to y or g of x is fine. And I have x, but there's nothing next to x that I'm adding or subtracting, so I'm going to do just plus a 0. Notice that my negative is still out in front. That is our a value, our negative 1. I'm asking you to identify certain things: vertex on the graph, axis of symmetry on the graph, and x-intercepts on the graph. So with an intercept form, we're going to always start with our intercept. So I'm going to have opposite of what you see here and here. So I have, even though this is a plus 0, it's just 0, comma 0. Here's negative 6, comma 0. I am going to highlight what we did. We've put in our x values. Our y values are going to be 0. These are your x-intercepts. Next, these x-intercepts are going to help you solve for the axis of symmetry. You're going to take these exact things, you're going to add them, and divide by 2. This is always cutting in half. So we get negative 6 over 2, which gives me negative 3 equals x as my axis of symmetry. We need this negative 3 to plug into my original equation. You always put things into your original. And you're going to solve for the y value. And that y value is going to be important for your vertex. So I'm going to put in negative 3. Careful with double negatives. That's why parentheses are important. I'm going to pick up my calculator. Let me find it. So I have negative down at the bottom, open, negative 3, close it, open, negative 3, plus 6, close it, equals, and I get 9. I'm going to put a thinking bubble around this because this y equals 9 doesn't answer anything. There's not like an answer for what is the y. Instead, together, combined, this gives you your vertex. So our vertex is negative 3, comma 9. This is important. We're going to put a box around it. Now this one is, I'm not asking you for a specific amount of points. Typically 3 points is good, and you already have 3 points for intercept form. I have 2 points here for the x-intercept, and I have my third point as a vertex. How to graph. Let's start like we usually did with our vertex and our axis of symmetry. That I do need to see. So we start at 1, 2, negative 3, and positive 9, 5, 6, 7, 8, 9. Yep. There it is. That's our vertex. Dotted line through the vertex as an axis of symmetry. And your 2, 0, 0, and negative 6, 0. Now again, your x-intercepts should be reflected over the x-axis. So if I were to count jumps, 1, 2, 3, 1, 2, 3. They should be reflecting over. Connect smooth U. and arrows. So mine is a little bit off, so I need to go back and fix it. I do encourage you to do this in pencil, definitely not in pen, because mistakes can't happen. Oops, that's even worse. There you go. So 3 points for intercept form is enough. Let's go ahead and graph intercept form again. Nothing missing on here. We got y is equal to negative, open, x plus 1, x minus 3. Start off with your x-intercept, so opposite of what you see. I see negative 1 comma 0 here, and I have positive 3 comma 0 here. These are your x-intercepts. These are important. Next, we're going to use our x-intercepts to find the axis of symmetry. Negative 1 plus a 3, always divided by 2. 3 minus 1 is 2. So our axis of symmetry is at 1. Make sure you write an equation. It is an equation of a line. Then we're going to open up our original. We're going to put in our axis of symmetry, 1. We're going to type this into the calculator. Negative, open, 1 plus 1, close it, open, 1 minus 3, close it, and I get 4. Again, thinking bubble because this does not answer any sort of question. This is part of our answer for your vertex. So together, we write that this is a vertex of 1 comma 4. And again, please read what it's asking you to do. If I'm asking you for 5 points, give me 5 points. If I'm asking you for 3 points, give me 3 points. If I'm not asking you for a specific number, give me enough. What does that mean? Enough for me to know that you know what you're doing. So I have 1 and 4 for my vertex. Dotted line for axis of symmetry through that vertex. And we have our x-intercepts at negative 1 and positive 1, 2, 3. Again, how do you check if this is good? Your axis of symmetry should be in the between your two intercepts. And curve, point down, curve, point down. Do we have a vertex? Yes. Do we have an axis of symmetry? Yes. Do we have our two intercepts? Yes. Moving on. Question number 14. Again, intercept form. Let's go ahead and do this exactly the same way as we did before. Starting out with our intercepts, again, opposite of what we see. So we get a negative 2 comma 0 as an intercept and a negative 6 comma 0 as an intercept. These are our 2 points. We're going to use our x-intercepts to solve for the axis of symmetry. We have negative 2 and negative 6 divided by 2 always. Negative 6 and negative 2 is a negative 8 divided by 2, which gives me negative 4 as my axis of symmetry. Please write that as an equation of a line. We're going to open up our equation. We're going to put in our x value, and we're going to solve for y. Our axis of symmetry was at negative 4. I'm putting in negative 4. Picking up a calculator, typing in exactly what I see. 3, open, negative 4, plus 2, close it. Open, negative 4, plus 6, close it. Equals. And I get negative 12 for my y value. Oops, negative 12. Negative 12. Thinking bubble, because this does not answer any sort of question, but it is part of our vertex when we combine it with our x value. We get negative 4 comma negative 12 as our vertex, and our vertex is going to be the third point that we need to graph. Let's start with the vertex. We got 1, 2, 3, negative 4, and negative 12, 10, 11, 12. Dotted line through the vertex, or dashed. And then we have our x-intercepts. We got -2 and -6. Again, check for symmetry. Yep, that's good. Smooth U, smooth U. Okay, that looks a little wonky, so I'm going to fix that a little bit. There we go. Arrows, if you don't have arrows, points are going to be removed. This is a continuous function, so it's going to continue all the way forever into infinity positive. All right, let's go ahead and move on. We are now moving on to standard form. Now, how do we know this is standard form? Because if we take a look at the equation, notice there are no parentheses. No parentheses means standard form. For standard form, we have a couple things that I'm asking you. Identify on the graph the vertex, axis of symmetry, y-intercept. Make sure all the points are indicated clearly. And then there's some other questions that I want you here to answer. Let's start with the equation f of x. You can also write y, -4x squared plus 8x plus 2. First thing you're going to do is you're going to start with the axis of symmetry. Axis of symmetry is a formula negative open b divided by 2a. If you are choosing to use a calculator, you must have extra parentheses in the denominator around your 2a. Otherwise, it will give you the wrong answer. Label your ABCs on your equation. Make sure to take the symbol with each ABC. So if it's positive, take the plus. If it's negative, take the minus. Let's go and fill in for your axis of symmetry. Negative open B divided by open 2, open A. Our B value was 8, positive, and our A value is a -4. So if you're typing this into the calculator, we have negative open 8, close it, divided by open 2, open -4, close it, 2 parentheses at the end if you're using a calculator. This gives me 1. Again, this is an equation of a line. This is our axis of symmetry. To find our y value, you're going to open up the given equation. Anywhere you see x, you're going to open up with parentheses. This is going to give you your y value for your vertex. So I'm going to take this 1 and I'm going to plug it in here. Again, use a calculator, please. -4, open, 1, close it, squared. -8, open, 1, close it, plus 2, enter, and I get -10. I'm going to put that in a thinking bubble here because that doesn't answer any questions, but it does give us our vertex. So I'm going to use the x and the y for the vertex here. Okay. Next, it's asking us for the minimum and maximum. Well, is this min or is this max? Here, you have a choice. You can either take a look at your leading coefficient, your A value here. If it is negative, that means you're going to be opening down. If it is positive, that means you're going to be opening up. If you want to wait on B, I guess I have two B's, but if you want to wait on answering the minimum and maximum, you can until after we've graphed it, and then it's going to be clear because you're going to be able to see if you're pointing up or down. Once you've done here and identified your vertex, somewhere off to the side, I'm going to do it here. Go ahead and create a T-chart for your points. Now, we can do something else here in just a few moments, but let's go ahead and focus on our T-chart. I'm going to start again with the vertex, and I am going to choose one direction. So I'm going to go 2, 3, 4. Since I already have this on my calculator, I'm going to go up and change my 1 into a 2, change my 1 into a 2. This gives me -30, which I'm not technically fond of. Okay, next I am going to go through, and maybe 3 is going to be better. Nope, that's even worse. And I am hesitating here because I'm thinking, why are my numbers that big, or technically small? I'm going to double check some things here and make sure that I I made a mistake. Hopefully you saw that. Let's go ahead and fix that mistake. I will use a red marker to fix my errors. And it's okay, I'm human. Hopefully you saw that. When I was writing down the original, it is a +8 and I wrote down a minus, which changed my vertex. Let me go ahead and fix that real quick. It will be a quick fix because I am going to plug in 1. And instead of having this plus symbol here, I'm going to, instead of having this minus, I'm going to put in a plus. 6. 6 is my y value. Hopefully, again, you saw that. Let's change that. This is y equals 6 and 6, which means all of these are going to be changed. 6. So when I type in 2, better, much better. Better, better, better. Let's do 3. -10. Okay, so we can do our points like this. So if they're asking you for 5 points, use a table. Let's do 4 because it's bothering me. And I get -3. Now, they are also asking you for the y-intercept. Y-intercept is your 0, c. So you don't technically need anything here. You can immediately identify your y-intercept through your c value. Don't change anything, just write it in your y spot. Now remember, a y-intercept is a point. Please make sure you have it as a point. Now this one is asking you to identify it on the graph. This is how it would look like. Let's graph. Let's start with our correct vertex of 1 and 6. Axis of symmetry. And let's start with our y-intercept at 0 and 2. The y-intercept is on the y-axis. Here is your y-intercept is 0, 2, and you want to identify that on the graph. Make sure that I know that you know where the y-intercept is. Now again, you can choose to reflect it, or we did create a table. I'm going to reflect it here. Let's go ahead and do our table. 2 and 2, 1, 2, 1, 2. Oh, that was already that point. 3 and -10. Here's 3, here's -10. And reflect that 1, 2 jumps, 1, 2 jumps. This one didn't technically ask us for a specific number of points. So minimum number of points is 3. I am able to fit 5 on this given Cartesian plane. Let's go ahead and do domain. I'm not even thinking about it. Domain does not change for quadratics, but range, I do need to go back to question number 2. For question number 2, or I guess it's not number 2, it's number 15, B, the first B. We're asking ourselves, do we have a minimum or a maximum? This is a maximum value, and the maximum is at 1, 6. We're looking at the y value for range. Remember, your min goes on the left, your max goes on the right. So since I have a max value at 6, 6 goes on the right. It is going to be in brackets, which means I am pointing downwards towards -infinity. Our minimum value with parentheses is -infinity. Is the vertex a minimum or a maximum? We're going to circle maximum. Let's go ahead and move on. Number 16, question number 16 is in standard form again. There should be an f of x here, but that's okay. It's without it. And we want to, once again, identify certain things. We want to identify the vertex, the axis of symmetry, and the y-intercept on the actual graph. Now, there is a section here that I want you to fill in as well. But let's go ahead and get going. We have 3x squared minus 6x plus 4 as our function. Let's start off with standard form. Now, how do we know this is in standard form? Because I do not see parentheses. When you label your ABCs, make sure, like this -6, you take your positives and your negatives. When you label your ABCs, that is because we need to use our axis of symmetry formula, which is -b over 2a. Remember, extra parentheses in the denominator. And you want to open up parentheses for negative b. So negative 6 goes here inside. We do end up having a double negative. And then for a, we have a 3. Now, if you are choosing to use a calculator, that is fine. You do need to use extra parentheses. So here's my numerator. Here's my top. A negative, open, negative 6, close it, divided by. Now here we need open, 2, open, 3, close it, close it. And we get a positive 1. Now remember, axis of symmetry is an equation of a line, so we want to put it as x equals. We are then going to open up our equation, and we're going to write in, ooh, I almost made a mistake, positive 1. Positive 1. Positive 1 is our axis of symmetry, not negative, positive. When we type this in, again, you want to type it in exactly how you see it. 3, open, 1, close, square, minus 6, open, 1, close, plus 4, and 1 again. This is our y value. I'm putting a thinking bubble around it because, again, the y doesn't answer anything. It's just part of your vertex. So 1, comma 1 is our vertex. Let's write that down here. Is the vertex a minimum or a maximum? I'm going to wait on that. Again, you can choose to take a look here. If this value, this leading coefficient, if it's positive, it opens up. So that means you're going to have a minimum for your vertex. But if you don't want to go based off of your a value, that's fine. Let's wait to sketch the quadratic function, and then afterwards we can just take a look with our eyes. Axis of symmetry, we're going to do that on the graph. Y-intercept. Now, y-intercept, as we saw in the previous example, if we take our c value, and this only works for standard form, y-intercept is our c value. So for the y, we have 0, comma, positive 4. Domain, I haven't even sketched anything, but I already know our domain is going from negative infinity to positive infinity, with parentheses, reminder that quadratic functions always have the same domain. And then let's actually go ahead and sketch. Notice I did not do a t-chart for this example, and I'm doing that on purpose. In the previous example, I believe question number 15, we did do a table, and I wanted to show you that yes, you can absolutely do a table. But because we know our y-intercept, we don't have to, we can just reflect that. Watch what happens. Let's start with our vertex at 1, comma 1. Here's 1, here's 1, here's our point. Vertex, V for vertex, dotted line. My y-intercept is at 0, comma 4. So here's 0, 1, 2, 3, 4. That's one jump, and you can see that I have immediately created, with the power of reflection across the axis of symmetry, 3 points. Now, let's take a look. We can see that we're going up. Since we're going up, that means our vertex, 1, comma 1, is a minimum value. When we're talking about range, we are talking about our y value. So here's the y value on the minimum. When we write domain and range, our minimum value goes on the left, our maximum value goes on the right. Since I have a minimum vertex, that means I'm going to open up brackets for my minimum value of 1. This is the y, not the x, the y. And then since I'm going up, that means my maximum value is at positive infinity. Make sure infinities are parentheses open. Let's do 17. 17 again is standard form. How do we know it's standard form? There are no parentheses. Labeling it ABC. Let's write this at 1/2 x squared plus x minus 3. We can label it y or f of x. Labeling our ABCs. Here's our A. Oh, be careful here. We do know our B, and here's our C. Our B is just one positive, so there's a secret 1 here for our b value. Let's do our axis of symmetry, negative b over 2a, and again, double parentheses if you're using a calculator. Our b value was a positive 1. Our a value is a 1/2. Now, because we have opened up parentheses to put in our substitutes, 1/2 ends up already being in a fraction, so you don't have to do extra fractions or extra parentheses. How to type this in? Negative down at the bottom, open, 1, close, divided by, open, 2, open 1/2, close it, enter, and I get a negative 1 here. Remember, axis of symmetry is an equation of a line, so we get x is negative 1. I'm going to copy this equation down one more time, open up for x. We do need to find our y value. Now here you do have to be careful because you do have 1/2. 1/2 does require parentheses when using a calculator. I'm going to take this negative 1 that I solved for, and I'm going to put that into our x value. I'm going to pick up a calculator and type this into the calculator. We get open 1/2 negative 1 squared plus negative 1 minus 3. Ooh, and we get a decimal. Remember, decimals are not allowed, so we need to convert that to a fraction. So I'm going to write it down just so I don't lose it, which we need to press second, PRB, which ends up giving us negative 3 and 1/2. We need to convert that. 3 times 2 or 2 times 3 is 6 plus 1 is 7. So for our vertex, we get negative 1, comma, negative, still negative. 2 times 3, that's 6, plus 1, that's 7, 7/2. Okay. Improper fractions is what we're looking for. Next, minimum or maximum, we can wait for that. Axis of symmetry, we'll graph it on the graph. Y-intercept, again, this is standard form. I'm going to pick up my c value here. Y-intercept is 0, comma c. This only works for standard form, so we get 0, comma negative 3. And with that, I am ready to sketch because I have the power of the axis of symmetry. Our vertex was at, we're going to have to guesstimate here where that negative 3.5 is. So we got negative 1 and negative 1, 2, 3. Here's negative 4, so 3.5 is here. Here's our vertex. Again, dotted line for axis of symmetry. It will always go through your vertex. Our y-intercept was at 0 and negative 3. Ooh, very close here. And reflect that over here. Curve, curve. Since we don't know what our x-intercepts are, I'm going to not touch my x-axis, and I'm just going to leave it at this. And now remember, the vertex is this point here, not this one. It just ends up looking like it. It's not. Vertex is this black point, not the ones that I did in pencil. Again, shifting this down, domain, immediately we know domain. Negative infinity, comma, positive infinity. That doesn't change. We go all the way from the negative axis to the positive axis. The range, again, let's take a look. Do we have this point here, this vertex point at negative 1, comma, negative 7/2? Is this a minimum or a maximum? Well, since we're going up with our arrows towards infinity, this does end up being a minimum value. And since we have a minimum value, that means when I take this here, when we write minimum on the left and we write maximum on the right. Minimum is now in brackets, negative 7/2, comma, our maximum is going all the way up to a positive infinity, parentheses. All right, let's continue. Question number 18 starts us off with our 3 variable systems. 3 variable systems have the same 3 steps always in the beginning. First 2 is going to be, you're going to take the first 2 equations, take the last 2 equations. First equations, negative x minus 5y minus 5z is equal to 2. 4x minus 5y plus 4z is equal to 19. In step number 1, you're going to choose a variable to eliminate. I'm going to choose this negative 5y and this negative 5y. So y is the variable that I'm going to choose to eliminate. Be careful here. Are we adding to eliminate or are we subtracting? So let's check. Negative 5 plus a negative 5 does not give me 0. But if I subtract negative 5 minus a negative 5, gives us a double negative. So I am going to be subtracting. I highly encourage you write in your pluses and minuses. Then we're going to use a calculator, please. Negative 1 minus 4 gives me a negative 5x. Negative 5 minus 4 gives me a negative 9z equals 2 minus 19, negative 17. If you can simplify here by dividing all terms, please do. Here, 5 and 9 and 17, they don't get along. Draw a thinking bubble around your first equation with two variables. Next, we're going to bring down the middle equation and the last equation. Now, step number 2, we have no choice. We must eliminate the same variable from step number 1. So in step number 1, I chose to eliminate y's. So in step number 2, I must eliminate y. Again, pick up a calculator, check how you're going to eliminate. So if I add negative 5 plus a positive 5, that does give me 0. So that means I'm going to add, and add. Dotted line for balance. 4 plus 1, that is 5x. 4 plus a negative 1, that is 3, positive 3z. 19 plus negative 20, that gives me negative 1. Again, if you can simplify here, please simplify. We're going to write these two on top of each other. So we get negative 5x minus 9z is equal to negative 17. 5x plus 3z is equal to negative 1. Draw a line underneath. Okay. Choose a variable to eliminate. We got two variables now. I am going to choose my x's because I'm noticing that these two are the same. Again, check whether you are adding or you are subtracting these. Negative 5 plus 5 gives me 0, so I'm going to be adding. I'm going to draw in my pluses. Negative 9 plus 3, that gives me negative 6z. Negative 17 plus a negative 1 gives me a negative 18. Remember, this is not where you stop. This is multiplying, so we need to divide by negative 6. Z is then equal to a positive negative 18 divided by negative 6, 3. Thinking bubble, reminder, this is not your answer. You're going to pick up one of your two variable bubbles, your two variable equations, and I'm going to open up for z because that is what I solved for. And I'm going to now solve for my other variable, which is x. Be careful when you type this into the calculator. Make sure that you're taking symbols. If it's positive, take the positive. If it's negative, take the negative. So we get a positive 9 here. 5x plus 9 is equal to negative 1. Subtract 9 both sides. 5 times x is equal to negative 10. Divided by 5 divided by 5, x is equal to negative 2. Dotted line, or dotted, not dotted, this is not a dotted line. This is a thinking bubble because this is not your answer. Okay, let's go ahead and bring these variables all together. We have one more variable to solve for, so I'm going to pick up the very first equation that they've given me. I'm going to write it out. I'm going to open up for x, make sure the negative is in front. I'm going to keep the y because I don't know what y is, and I'm going to open up for z. X is negative 2. Z is a positive 3. Here where you need to be careful, and you need to be careful here. So negative gives me a positive 2. Negative positive gives me a negative 15. Combine like terms. So we get 2 and a negative 15. That gives me negative 13. and a 5y. Add 13 of both sides. Bring down the 5 times y. Divide. Divide. Y is then equal to a positive 3.
I am interrupting this video with a quick correction. It was brought to my attention. Thank you to the person who brought this to my attention. I did make a mistake when I was copying down here with a negative 5y. I accidentally put a plus. I am human, and humans make mistake. So I'm going to learn from my mistake, and I'm going to fix that. There should be a negative 5y, so a negative 5y, which would make this a negative 5y here, which would then make, don't mind this, I already recorded that, you'll see that in a few moments, which would make a negative 5 here, a negative 5 here, and a negative 5 here, which would give me a negative 3 on y. So again, let me highlight the mistake that I made. So make sure that you have a negative 5y, which would make this a negative 5y, a negative here, a negative on 5, a negative on 5, a negative on 5, which would give us y equals negative 3. Again, thank you to the person who pointed out this error. Your answer should be negative 2, negative 3, 3.
Going to move on. Question number 19. Remember, the first 3 steps are the same. We're going to write out the first 2 equations, write out the bottom 2 equations, then we're going to bring those 2 thinking bubbles together. So let me go ahead and draw a quick little line here separating out so I don't get confused. And I'm going to write these 2 on top of each other. 5a, make your a twirly and your b's a little bit straighter. Here we have 4a plus 3b plus 3c. And now as I'm writing this, I'm a little bit disappointed nothing's matching. So it looks like I am going to need to multiply. And then the bottom 2, 4a plus 3b plus 3c. And I am noticing the bottom 2 are they matching? No, not really. Okay. So I can, looking at here, I can choose A, B, or C. Any one of these are going to be good for step number 2. It all matters what I choose in step number 1. So in step number 1, I'm just going to choose to deal with A just because I can. So that means my top equation is going to be multiplied by 4 and my bottom equation here is going to be multiplied by 5. Be careful when you're distributing. Every single thing gets a multiplier of 4 and every single term gets a multiplier of 5 on the bottom one. So we get 20a plus 20b plus 20c equal to negative 2. Oh, just kidding. Almost forgot. Negative 80. Here on the bottom, we get 20a plus 15b plus 15c is equal to negative 30. Okay, what's my goal? My goal is to eliminate a. So I'm going to subtract 20 minus 20. Double checking on a calculator does give me 0. So then next here, I get 20 positive minus 15. I get 5b. 20 minus 15, I get positive 5c. Negative 80 minus negative 30 gives me a negative 50. So I am going to simplify this by dividing everything by 5. So I get b plus c is equal to a negative 10. Okay, my first thinking bubble. Since I eliminated a, I have to also eliminate a in step number 2. I don't have to do anything here except check that I can do zeros. 4 minus negative 4 does not give me 0. 4 plus negative 4 does give me 0. So I will be adding my terms together. 3 plus 3, I get 6b plus 6c. Negative 6 plus 9, I get 3. So be careful here. I did divide everything by 5 to simplify. I still can simplify, absolutely. But I can't divide everything by 6 because this will end up being a fraction. We don't want to deal with fractions. So instead, I am going to simplify by dividing everything by 3. So I get 2b plus 2c equals 1. Pick up my 2 thinking bubbles, and I am going to write this on top of each other. I got b plus c equals negative 10. 2b plus 2c is equal to 1. Choose a variable to eliminate. I'm going to choose b just because it's in the front. So that means I'm going to be multiplying the top equation by 2. So I get 2b plus 2c equals negative 20. 2b plus 2c is equal to 1. Again, here, make sure you're not letting your eyeballs play tricks on you. Keep going with the steps. And our steps are to eliminate the variable of our choosing, and our choosing is b. I'm going to remove that by subtracting. So I have 0c is equal to negative 21. So 0 is equal to negative 21, and that is a false statement. Remember, false is not your answer. False is just saying 0 is not negative 21. So what is your answer is no solution. Okay, let's go ahead and move on. Number 20. Same first 2 steps. This one's printed out a little bit blurry. X minus y plus z is equal to negative 3. X minus y minus z is equal to negative 3. And then the bottom 2 equations are x minus y minus z is equal to negative 3. 5x minus 5y plus z is equal to negative 15. Let's start by choosing a variable to eliminate. I'm looking at my z's in step number 2, and I'm looking at my z's in step number 1. So I'm going to choose z to eliminate. That way I don't have to multiply anything in step number 2. Remember, in step number 1 and step number 2, the variable that you eliminate must match. Now, do we add or subtract? We are checking on a calculator. 1 minus a negative 1 gives me not 0. So 1 plus negative 1 does give me 0. So I am adding. One plus 1 is 2. Negative 1 plus a negative 1 is a negative 2. Negative 3 plus a negative 3 is a negative 6. Simplify if you can. So I'm going to be dividing by 2. We get x minus y is equal to negative 3. Thinking bubble. Here again, we are going to be adding. Double check whether you're adding or subtracting. That removes your z's. I get 5 plus 1 is 6. Negative and negative 5 gives me a negative 6y. Negative 3 and a negative 15 gives me a negative 18. Simplify if you can. So I'm going to divide everything by 6. So I get x minus y equals negative 3. Okay, don't let your eyes play tricks on you. Keep going with step number 3, which is taking our 2 equations, writing them on top of each other. X minus y is equal to negative 3. X minus y is equal to negative 3. Choose a variable to eliminate. I'm going to be choosing x. And to eliminate x, I will be subtracting. X minus x is 0 x's. Negative 1 minus a negative 1 is 0. Negative 3 minus a negative 3 is also 0. So we get 0 equals 0, which is an always true statement, which means you're not done. That means we're going to have dependent solutions. So we are going to pick up, I have space here, so I'm going to pick up one of my equations. I'm going to say x minus y is equal to -3. And I'm going to choose to solve for one of the variables. I'm going to choose to solve for x by adding y to both sides. So we have x is equal to y minus 3. Okay, what does that mean? That means x is dependent on y, which means y is independent. And so I usually like to write things out like a little side. What do we need? Kind of like what's the whole point of what we're doing? Well, the whole point of what we're doing is to solve for x, y, and z. X we figured out was y minus 3. Y was independent, so that means we're going to keep it. I don't know what z is, so I need to solve for z. When we go to solve for z, we're going to pick up one of the original equations. Again, I just choose the one that's on top. It doesn't really matter which one you choose. Let's bring it all the way down. We're going to copy and open up for x. We're going to keep y because it's independent, and I'm going to keep z because that's what I need to solve for. Now, what was x? X was y minus 3. Go and drop your parentheses here if you need to distribute or anything like that. Let's do that, but we don't need to. So we got y minus 3 minus y plus z is equal to -3. A y minus a y, these are like terms, those are gone. We get -3 plus z is equal to -3. I am running a little out of space, so I'm going to continue here. I'm going to add 3 to both sides. Z is then equal to 0. Per usual, I need to find some space for my answer. I have space all the way in the front, on top. Here's my little answer box, or I guess big answer box, parentheses, comma. Again, what do we write? We write in alphabetical order, x, y, and z. X was y minus 3. Y was independent, so we keep it. Z was 0. And that is our answer. Okay, moving on. Now we are writing equations. We want to write both of these in vertex form. Vertex form is y equals a times x minus h squared plus k. Keep in mind that we are not writing a b because b now is absorbed into your a value. You're going to label your vertex h and k. You're going to label your point x and y. Be careful with the only one that changes, and that is your h value. When you put in your h, it's opposite of what you see. Y is -24. A is unknown, so we keep it. X was 0. I see a -6, I write a +6. Square it, K was -12. Be careful here. A lot of times we combine things that shouldn't be combined. So you're going to remove this K value first by adding 12 to both sides. This prevents you from adding things that cannot be added. Next, we got a times 6 squared here. We got -12 on the other side. We got 36 times a. You can rearrange it if you want, or you can keep it. But I did square 6. I'm going to divide by 36, divide by 36. And here's where, yes, you can use a calculator. Decimals are absolutely not allowed. So it will give me a decimal here, but again, decimals are not allowed. So you're going to press second, you're going to press PRB to convert fraction to decimal, and it gives me a simplified a value of -1/3. Putting this in a thinking bubble, this is not our answer because we need to write the equation. Now they do want the form of f of x. So f of x is equal to, what is a? -1/3 times x, keep your x, opposite of what we see h, square it, must be squared, minus 12 for our k value. Please be careful about your squared. If you don't square it, you have given me a different parent. My example always is if I ask you to bring me a puppy and you bring me a cat, that's not the same thing, right? Not what I asked for. Example number 2. I guess, yeah, B. H comma K, X comma Y. Let's write this out. Y equals A times X minus H squared plus K. Y is negative 15. A is unknown, we keep it. X is negative 7. H is, again, opposite of what we see, so I'm going to write a positive 5. Square it. K is a positive 9. When we're solving, please make sure to remove your K value first so you don't combine things that shouldn't be combined. Then we can go back in here and say negative 2. Well, let's go ahead and do this negative 15 minus 9 first, which gives me a negative 24. Here, I do encourage you to use a calculator to do negative 2 squared. If you do that, you must have parentheses around negative 2. Sometimes things get mixed up with our positives and our negatives. Here, I'm showing you how we just keep that 4 on the right-hand side. That's fine. Make sure you put in your little multiplication dot so it triggers your brain to divide. Negative 24 divided by 4, oops, is a negative 6. Again, thinking bubble because this is not your answer. Let's write it in the form of f of x. Our a value is negative 6. Open, x, h was negative 5, so we write positive 5. Make sure you square it. K was a positive 9. Okay, give you a few moments to look at that before we move on. Moving on. Oh my goodness, it's the last page. Hang in there. All right, question number 22, again, write in the form of f of x. This time it's asking for intercept form, so we have a different format. We have y equals a times x minus p, x minus q. Now, your p's and your q's are inside. These are going to be opposites, but they're going to be from your x-axis. So here's your x-axis, and we're looking on the x-axis for our x-intercepts. So when we write our p's and our q's, let's say we take this negative 6 that I have here. When I write it in here, it's going to be opposite of what I see when I pick up at negative p. When I take this negative 3, it's going to be opposite of what I see when I pick up this q. Now this point that I have here, this is going to be a random point on the curve, and this is your x and y. How do you do this? Negative 6 is your y, a we keep, x is negative 4. I'm going to skip p for right now. So when we write in the p and the q, I see a negative 6, I write a positive 6. I see a negative 3, I write a positive 3. Make sure you do opposites for your p's and your q's. Here, this section right here is all multiplicative. Yes, you have addition inside parentheses, but the parentheses are being multiplied between each other and a. So we can type this into the calculator and press enter. So I have negative 4 plus 6, close it. Open, negative 4 plus 3, close it. And I get negative 2. Negative 6 is equal to a times, put the little multiplication dot, negative 2, divide by negative 2. A is then equal to a positive 3. Thinking bubble, this is not an answer for anything. To write your equation, we got y equals, a is now 3, open, x, plus 6, opposite of what you see, for p, and x, plus 3, opposite of what you see for q. Here's your equation in intercept form. Now, when sometimes they'll do x-intercepts like this, or sometimes they'll even call them zeros, this is not a point. This is actually 2 points where they've given you an x-intercept at 9, 0 and 1, 0. Same thing here, x-intercepts, so negative 1, 0 and 2, 0. Again, sometimes they call them zeros. Sometimes they call them x-intercepts. Sometimes they even call them roots, R-O-O-T-S. We label them here, x, y, for our point. And I'm kind of doing both examples at the same time, which is weird. Let's not do that. Let's focus on this middle one. Let's write out our form, y equals a times x minus p, x minus q. Remember, your p's and your q's are going to be opposite of what you see. Keep your a, that is what we need to solve for. X is 0, I'm going to leave some space for the p, and I'm going to leave some space for the q. When you pick up the x-intercept that you see here, you're going to write opposite of what you see, so I'm writing a -9. And here I'm writing a -1. This bottom section right here, or the 2 parentheses, can be typed into the calculator. So we got 0 minus 9, open, 0 minus 1. And again, let the calculator do the thinking for you so you don't accidentally make a mistake. Multiplication dot here, which triggers us to divide. And we get -2 for a. Writing out our equation, y equals -2, that's our a. X, opposite of what we see, so -9 for our intercept, and -1 for our intercept. Exactly the same thing here. I'm jumping right in. Everything has been pre-labeled. Y was, fractions. Don't let that scare you. That's exactly the same thing. So -21/4. Solving for A. X was 1/2. I'm skipping P. What are our intercepts? I get 1 at, again, opposite of what you see, so +1. And opposite of what you see, -2. Now, be careful here. This is an alert. When you have fractions like this, you have to put extra parentheses around them, especially if you're using a calculator, which I will be doing because I don't want to deal with fractions. You can still type everything in and then press enter. Just make sure you have extra parentheses. This is how it's going to look. Open, open 1/2, close, +1, close, open, open 1/2, close, -2, close. Decimals are not allowed. Second PRB, enter. Mixed numbers are not allowed. So right now I have -21/4 is equal to A times -2 1/4, which again, I can't have that. So I'm going to reconvert that to an improper fraction. Keep the negative, that stays. 2 times 4 is 8, plus 1 is 9. Keep the denominator as 4. Here, again, you can either multiply both sides by the reciprocal, or you can use a calculator to divide. To divide, we're going to divide exactly what we see on both sides, dotted line for balance. If you're doing this by hand, you have a fraction divided by a fraction. This is going to be a keep, change, flip. If you don't know what I'm talking about, don't worry about it. That is something we're going to focus on a lot in our next chapter. So, parentheses, -21/4, close it, divided by, open, -9/4, close it, enter. Again, we get a decimal. Are decimals allowed? Absolutely not. We're going to press second PRB. 2 and 1/3. Are mixed numbers allowed? No. So we're going to, again, this is a positive. 3 times 2 is 6. Plus 1 is 7. Putting this in a thinking bubble. Let's go again. Y equals 7/3 for your A value. X, opposite of what you see, so plus 1. X, opposite of what you see, -2. Make sure to simplify. When you use a calculator like this, it does do the simplifying for you, but sometimes you have to convert to impropers. Convert your fraction into standard form. Standard form is also known as expanded. So we have to multiply things out. This is in intercept form, so we have 3 times. And so the first thing you're going to do is you're going to distribute these here. So x times x, and I'm going to keep it in parentheses, you have to, is x squared. X times 4 is a 4x. -3 times x is a -3x. And -3 times a +4 is a -12. Combine like terms on the inside of the parentheses. Keep your parentheses. So we got x squared plus 1x minus 12. And because we had this a value of 3, we're going to need to distribute inward to have 3x squared plus 3x minus 36. And that is going to be our either f of x, g of x. You can still call it y because it is the same thing, just looks slightly different. And then for the very last one, this one does come with an alert. Because we are expanding, we first have to expand this bubble squared. And someone's going to ask me, well, do I really need to expand this and write it twice? Absolutely, yes. You have to. Otherwise, you're not going to be able to distribute the way that you need to properly. You can also use box method. Let's do box method since I did use distribution here. For the box method, you're going to draw a box. You're going to pick one of the parentheses, one of the bubbles, and on one term I have 3x, the other term I have -4. For the other parentheses, I do have a term of 3x and a term of -4. Now this works just like a regular multiplication table where you're going to multiply 3 times 3, 9, x times x is x squared, and then write your product, write your answer inside of the box. 3 times -4 is a -12x. -4 times 3 is -12. Then we have x. Negative gives us a positive. 4 times 4 is 16. With the box method, things on the inside diagonally typically combine like terms, and you're always going to add these together. So we got -3 on the outside. This is still parentheses and a 1 behind it. Inside, I got 9x squared minus 12 plus 12 is 24x plus 16. This right here, this plus 1 needs to go last. So we need to distribute that -3 inward. And then the very last thing we're going to do is add that 1. So 9 times -3, I get -27x squared. -24 times a -3, I get a positive 72x. 16 times -3, I get a -48. Then I can bring down my plus 1, combining like terms. So f of x is equal to -27x squared, plus 72x minus 47. And this is our expanded form. All right, beautiful people, that is it for your homework. Thank you so much for watching. Hopefully you made it till the very end, and I will see you in class. Bye.